So I want to thank everybody for coming to the webinar. And at this point, if I think there were some questions that came through that I was able to work into the content, and a lot of requests for the poster. But I want to be respectful of anybody's time. And if you have to go, then that's completely fine. I'll leave this slide up. But if there are any questions that I hadn't answered, then I invite you just to hang out for a bit, and you can put those in the Q&A box in the Zoom software, and I'd be happy to answer those. So, here's a question that came through. On this inspection, you have private build and integration build. What's the difference? All right, so that's a good question. Continuous integration, way back in 2006, there was the book from Addison Wesley Press about continuous integration. And in that book, continuous integration was defined as 3 stages. The first stage is called the commit stage. That happens completely on developer's workstation. The second stage was the integration stage. That happens on a team shared server of some sort, where changes from multiple team members are integrated, and then a new build of the software is created. And then the third stage was the first deployment. And that was deploying the results of your integration build to some type of environment to verify the integration build. Okay, so continuous integration has 3 stages. The first stage is your commit stage. And so the private build is a tool that helps you execute that first stage. And it gives you the build script that cleans up artifacts just to get ready. Every build is in fact a test. So every build is responsible for its own environmental setup, but it runs the build, compiles your code, then runs as many tests as can be run on a developer workstation. Your unit tests, your component level integration tests, and whatever checks you can pack into reasonably into running on the private workstation. It also does environment setup, like creating a local version of your SQL Server database so that your component level integration tests that run SQL queries actually have a database to run against. And that's usually in PowerShell, just simple shell scripting to do that. And that answers the question for you: with the changes that I just made on my branch, am I ready to commit my code, or did I just break something? And do I have a unstable software system now, and there's no point in committing? Because if the build finishes, I know that I'm ready to commit and push my code up to my feature branch, and I can do that. And then the actual act of committing and pushing it to your Git repository, that finishes that first stage of continuous integration. And then the integration build, well, it uses the same script. Mechanically, it uses the same PowerShell script to do the same types of things, but it exists for a different purpose. It doesn't answer the question, did you break something? It answers the question, with all the changes from multiple different places and multiple branches merged into a single branch, with the combination of changes coming in from multiple places, do we still have a stable software build, or did that combination of changes just break something? And then if that particular part passes, then the integration build finishes up by packaging the different deployable components of the application and creating those deployable packages, whether they be NuGet packages or zip files, and it stamps them with the name of the application and the build number, and then archives them in whatever package manager you're using, whether it be Azure Artifacts, or whether you're pushing it to Octopus Deploy, or putting it somewhere in a directory of zip files. So that's the difference between the private build and the integration build. Both are hugely important. And we see teams a lot of the times, they'll configure Azure pipelines or GitHub Actions, and they trigger on a change to the master branch in Git, and all they do is run .NET.exe build, which is effectively just a compile, okay? Compile and linking of libraries. And when that's the only check you have, you're not even running tests. You don't have a quick feedback cycle. Now, let's say that you did have test libraries and you ran them there, but you didn't run them locally. Well, when you break something, you don't find out immediately locally. You've got to wait until you push it and share it and do it on the shared server. And now you've got a broken build. Now you've got to roll back source control, and it's a lot slower development loop. Okay, so that's really important. All right, I think we've got all those questions answered. Okay, awesome. Well, thank you for that. And for the other people who submitted questions while I was talking, I was kind of able to work that in as I was going through the content. So I appreciate that. Thank you all for your time. And I hope you have a really, really great Thursday, and God bless.